Yes, so my name's George. I'm at the University of Birmingham. I'm doing my PhD, and this is just a little window into the research I'm doing. My PhD is based on the urban shrinkage in China, and this particular bit of research looks at the spatio-temporal patterns of said research. So as we all know, China's been facing massive amounts of urban growth over the last 3 decades. But this is not homogeneous across all of China. There are some cities and regions facing problems with urban shrinkage, i.e. the loss of population. And with that comes housing vacancy issues, issues of infrastructure not being used properly, and natural environment issues. So it's a big problem. And another problem with this research is that the process of a city shrinking does not follow one basic pattern. It's quite hard to identify why a city shrinks. There are lots of different reasons, whether that's competition from nearby cities and other reasons like that. So we need to create a typology in a way to study urban shrinkage on a national level. And little research has been done towards this. So this research tries to build a way to identify common characteristics of shrinking cities in China. And hopefully this will help inform different solutions and national strategies across all of China. We focus on a pixel level, so we use nightlight data to then focus on a pixel level, but then build it to compare to the national region. So we use 2 sets of data here. The first is nighttime light data. Urban shrinkage is quite hard to study based on other forms of satellite data because unlike urban growth, when you can see urban growth when a new building is built, whereas urban shrinkage, if the population moves away, the building can remain there for many years. And it's quite hard to identify whether a city is shrinking based purely on looking at it. Population statistics are unreliable, and the temporal resolution is also quite poor, having to rely on census data. In China in particular, administrative boundaries change regularly. They're very inconsistent between provinces, and every province collects it at different times of year and in intermittent years as well. So nighttime light data allows us to monitor the human activity of regions, and then so it allows us, rather than the exact population, there's lots of research using it, comparing it to population data. And this is one way of looking at human activity in relation to urban shrinkage. We take 20 different years of the nighttime light data, and we take one on an annual basis, and it has a spatial resolution of 5 meters roughly. And then we also use the point of interest data. Point of interest data is good because it is a lot, unlike the nighttime light data taken from different satellites, point of interest data is very specific with its geographical coordinates. And obviously there's more points of interest like mailboxes, cafes, restaurants. These are all loaded from Google Map, and they're a lot more specific, so there'll be a lot more in urban areas. So it's good to combine them in order to get the urban extent of the region. So this is what we've done. We have our point of interest data, and we take the current density of that, and then we have our nighttime light data, for example, in 2018, and we build a composition data to get what some people would call the natural city. So this gives us the urban extent. And from this, we're just focusing all of our research on that pink region you can see on the right there. So from that, we then have 20 different years of pixel data of just the urban regions in China. We then calculate for each pixel, we layer them on top of each other all the years. We split them into 3 different time zones, the whole time zone, and then we split them in half. And we calculate the trend over the 20 years, 10 years, the mean, the standard deviation, and the maximum values of each pixel. And then from that, we will then cluster in order to create a typology of shrinkage. So each pixel, there'll be some that are typically shrinking throughout the years, and we create a typology in order to compare different regions within cities in China, but then across on a national scale. And we found, through lots of different testing, we found 6 different clusters of pixels to be up to the number. And an example of this can be seen here. This is between 2000 and 2019, so this is the whole data. We identified 6 different clusters. So we named them high-level shrinkage, which is trending downwards, and that's in the high-level meaning they were already quite high, so it's central urban areas that are shrinking. You have another example at the bottom there, urban sprawl, they're quite low low density, but they're slowly growing outwards. And I think it's a lot easier to see when we map it. So these are two examples, two very different examples. On the left, we have a city or a region that's growing a lot quicker and has been growing throughout the time period studied. And you can see there the amount of urban sprawl, but also there are regions that are experience the shrinkage. And it's important that we can use this to identify the different regions. Now we have the regions, you can look deeper into the reasons why. Beijing, for example, had a large patch of shrinkage. But when you look why, it's because the government had a policy of getting rid of people in the main central area and spreading them outwards for pollution reasons and other reasons like that. But it's interesting to see the different patterns of it based on the spatial level. And then Beijing is northeast China, a region, once an industrial powerhouse of the northeast of China. It's been suffering shrinkage for many years as industrial decline is a key cause of urban shrinkage. So that's what it looks like at a very basic city level. And obviously you can do this for any region you're interested in. And then we can aggregate it up by taking the average. So you can look at regions that typically have a high level shrinkage in the city. So northeast China, as expected, where most of the industrial areas are located, they tend to be the regions that experience a high level shrinkage. The rapid growth is another example where around Chongqing, you're expecting rapid growth, and that's exactly what we're seeing. And then the applications of this is you can use this to create a typology of what you're seeing in one city compared to another. Urban shrinkage is so multifaceted, and the government is trying to create policies to address it on a national scale. This is one way of identifying common trends and patterns across the whole of China based on a very local pixel level.